This lesson deals with supplemental problem 220. You can find this problem in the ECE302 ebook in the Chapter 2 Supplemental Problems, starting on page 43. The circuit shown below here was featured in a magazine article in Radio Electronics, volume 62, number 8, and the article was entitled Voltage Doublers. And in that article, it said that this was a quadrupler circuit. If you look at this looks very similar to the design we did in supplemental problem 218, except that the capacitors C3 and C4 are wired differently. Let's see if we can explain what's happening. Our SPICE file would be the same, except that we're just going to rewire C3 and C4. C3 is now going to be between nodes C and A, and C4 between D and B, instead of being between D and ground, and being between C and in. Same steps, same models. Let's see what happens. I first plotted V sub A, which is the node voltage of the first clamp, and you can see it's tending towards 23.5 and minus a half a volt. Then I did node voltage B, which is the first peak detector circuit, and it's tending towards 23 volts. And I plotted V sub C, which is the second clamp, is tending towards 46.5 and 22.5. Then lastly, plotting node voltage D, which is the second peak detector, and it's tending towards 46 volts. So these are the same endpoints we had in supplemental problem 218 and 219. The cycles and the values in here as we're going to these final values may be a little bit different, but the endpoints are the same. So it does the same function. Let's take a look at the capacitor voltages. The voltage across capacitor C1 is between nodes A and N. That's 11.5 volts, and that was the same value we had in our supplemental problem 218 and 219. And then I applied the voltage across capacitor 2, which is node voltage B, and it's tending towards 23, and that was the same value we had in our previous quadrupler circuit. I plotted the voltage across C3, which is now between nodes C and A instead of C and N, and now I get 23 volts, which is less than what we had in supplemental problems 218 and 219. And then lastly, plotting the voltage across C4, which is now between D and B instead of D and ground, it's also tending to 23 volts. The maximum voltage across C3 and C4 is now only 23 volts instead of what we had in supplemental problems 218 and 219, which was much higher. Can we explain why this is happening? If you recall in supplemental 219, we looked at the capacitor voltages in the circuit, and we saw that the capacitors look like short circuits for AC signals in steady state. Knowing that fact, let's go back and take a look at page 43 again. See if we can explain what's happening. It's in words here, but let's take a look at it here. For this first capacitor in our original quadrupler, this was at 11.5 volts, and it still is. The voltage between here and here, which was across C3 in our supplemental problems 218 and 219, was 34.5 volts. Now by moving that wire from here to here, the voltage I have across here now is going to be 23 volts. We're able to lower this voltage by moving this wire over, because in steady state these both look like short circuits for AC signals. By doing that, I can lower the voltage rating on this capacitor C3. The voltage across here in supplemental 218 and 219 was equal to 23 volts, and it still is. But the voltage between here and here was 46 volts, and that was the voltage across C4, so the voltage rating would have to be at least 46 volts. But by picking that wire up from here and putting it over here, I now put 23 volts across here and across here, so now I get the 46 volts. A little bit of rewiring here was quite clever. It's a way to lower the ratings on the capacitors for maximum voltage and thereby lowering its cost without changing the AC response as well as the DC voltages. And this is supplemental problem 220.